it is on Earth or anywhere else in the world, it is light. Okay, na? Anything that is the fastest would be light only. Okay, na? Light
Sir, I want to
roughly
tell one thing,
travels.
sir.
Repeat again.
Sir, actually, I've heard that light is not the fastest thing, and that sometimes that when uranium reactions happen,
Hmm?
sometimes electrons are forced to go faster than
Hmm.
the speed of light. I've heard about that, sir. Could
You're saying
that be
that
the fastest thing?
in nuclear reactions, electrons are made to go faster than the speed of light.
Yes.
See,
And
actually in nuclear,
nuclear fusion as well. Nuclear fusion.
yeah, like
No, no, no.
see, yeah, it is to some extent it is observed that like indeed we can make them to move faster than the speed of light, but only within a medium like water and not only in mediums like in water. And that phenomena like
Yeah.
it's called as if you were to study about radiation in higher classes, you will learn that it is called as
Yeah.
Cherenkov radiation. Okay, na? Cherenkov radiation. Getting it now? So like it can travel
Yes.
faster than the speed of the light in a particular medium. Okay, that's why you will see that if you have seen such videos like in the nuclear power plants now, the nuclear reactive materials, they are basically submerged into the water. Getting it? That is submerged under the water. Have you guys? Do you guys have
So
any
that they
idea?
can like
Yeah,
it needs a viscosity. It needs like
viscous.
a surrounding which has viscosity. Is it like
Hmm.
that?
It is like that, or basically it needs to be in a medium like in water. It cannot happen in vacuum. Getting it? No? So
Okay.
that is the thing. Okay, but however, we see that
But
like this.
technically, light is the fastest because it
Technically,
is the only thing that can go through all mediums. So it's the fastest
hmm,
technically.
exactly, right. So it's a very rare phenomenon that in the Cherenkov radiation, like there's a matter that is going faster than the speed of light. So it actually happens. Okay, now very good thing you have mentioned here, by the way. Okay, good. Let's continue from where we have left. We were doing the chapter motion and time. Okay, and so far in the chapter we have learned about motion and sorry, we learned about different types of motion, right? Like we did learn about the rectilinear motion. In this, we learned that whenever a body is moving in a straight line without changing its direction, so that body is said to have a rectilinear motion. Sometimes rectilinear motion is also called as translatory motion. Okay, na? So don't get confused. Both are referring to the almost same thing. Okay, so
Translatory also means curvilinear.
which one? Translatory.
So, in my textbook last year,
Mm-hmm.
translatory motion refers to curvilinear motion as well.
No, no, no. That's a different thing. That's a different thing. No. See, so we have many
Okay.
examples of rectilinear motion, like you're basically pushing a box placed on the ground or on a table, march past done by the students on a straight path, or an apple falling from the tree. Right now, it does not fall to the earth in a curved manner. No, it simply falls to the earth in a straight line. Then we had circular motion. We learned about this when a body will be moving in a circular path along a fixed distance from its center, at a fixed distance from its center, right? So that is called a circular motion. The body is said to be in a circular motion if it is moving in the shape of a circle about a fixed point. Okay, and that distance between the body from its center will basically is radius. Now you know about radius in
Yeah.
maths. You would have learned about circle now, right?
Yes, sir.
Getting it? So in this case, this is a piece of thread and a stone. A stone is being tied with the help of a thread and is being whirled around by this boy here. So the stone is moving in a circular path at a fixed distance from the hand of the boy now, and this thread will be calling this the length, the distance between the hand, like where it is, he is holding the thread and the stone, that is radius here. Getting it, guys? Here also, this is radius basically. Okay. Further, we learned about the oscillatory motion also. In the case of oscillatory motion, what we have learned that like a body will be repeating a particular kind of motion. It will keep on repeating a particular kind of motion. So if you have seen the pendulum clock, how the pendulum moves on a this clock, right? So it keeps on moving in this manner. Getting it, guys? It does a forward and backward motion. Like we'll go over here and here and here like this. So it is repeating this kind of motion. Getting it, everyone?
Yes.
So right now we are learning in detail about the oscillatory motion, okay, or sometimes also called as periodic motion. Okay, now periodic and oscillatory motion almost they are like they are all the similar, but slightly there's some difference in it. Okay, now
Oscillatory motion cannot be periodic motion, but oscillatory motion is periodic motion. But periodic motion means anything that repeats itself. But oscillatory motion is the one that's moving to and fro. So they are not completely same.
yeah, but in a general sense, we study them together. Okay, now generally we study them together. Like when we talk about the rotation of the Earth, revolution of the Earth, so they will be considered as periodic motion because the Earth will repeat its rotation at after some time it will repeat the same motion. Getting it now? It takes a particular period, fixed amount of time is taken by Earth to do rotation and revolution. Salman is there. How are you, Salman? Good. Status called as periodic motion. Getting it, guys? How do we define the periodic motion? So we see that
Yes,
a
sir.
motion that repeats itself in equal interval of time. Like every 24 hour, after every 24 hour, Earth would have completed its rotation now, right? After every
Sir, but
365 and
it's
one,
like sometimes changes. It sometimes changes. It depends. Sometimes.
there could be slight variation in the time period of the Earth's rotation. Okay, now, but generally what we see that it can vary slightly due to some factors like it has got to do with the climate change. Sometimes it can be related to the like tidal forces, but they are very very small. Getting it? And you know like how small they
About
are?
a few milliseconds. Milliseconds less.
Milliseconds. Exactly, they are measured in milliseconds. Okay, na? That's the thing. So we generally ignore
Especially
that.
in summers.
Yeah. Okay. So what I was saying that I was talking about the periodic motion. So periodic motion, in this we have the examples like rotation of Earth, right? Then you have revolution of Earth. Getting it, guys? Revolution of Earth. So in this, the motion of the Earth will be repeating itself in equal interval of time. Like the rotation of it takes about 23 hours and 56 minutes and 56 minutes and a few seconds. Approximately it is 24 hour, right now. So 24 hours. So after every 24 hours, the Earth will do another rotation. Then revolution of Earth takes about 365 and one fourth of a day, right?
Sir, I have
And
one
after
doubt.
this, it will keep on repeating its revolution. Yes, Abhiraj.
Sir,
Hmm.
sir, one player. I think so. One island is there nearby Russia. We can see day and night equally.
You're saying, like, clarify your question. What exactly you mean to say?
So, sir, in previous chapter, I think so.
Mhm.
No in sixth class I
Mhm.
learned about one chapter. They
Mhm.
said that in one place in I think so nearby Russia, any countries there the light will in the sunlight will, the sun is this the
Okay, I
sun
got it.
will.
I got it. I got it. See, basically, you are saying that in certain parts of the Earth, the duration of day and night is equal. Is that what you're
Yes,
saying?
sir. Yes, sir.
Hmm. So there are times when the duration of Earth and night will be equal on Earth. Okay, na? it happens almost twice a year. Okay, na? Almost happens twice a year. One is between 20 to 21st of September. Okay, na? Sorry, 22nd to 23rd of September, I mean to say. 22nd to 23rd of September. Another is around March of 20 and 21 March. Okay, na? So on these two different occasions, we find that the duration of the day and night is equal. Day is equal to night. Okay, that is the thing over here. Then we find that in certain parts of the earth, like there won't be sunrise for about 5 or 6 months. I think you were mentioning about that also, I think. So particularly
Yes,
the
sir.
areas near the poles where the sun will not rise for long period of time, we see that like it could be up to 6 months. Up to
6
6 months.
months. 6
Getting it?
months.
So
And then 6 months light.
there will be sunlight. Getting it? No? So particularly the area that is lying in the Arctic and in the Antarctic circle, na, they'll be experiencing this thing. There'll be continuous period of darkness or daylight that will last for several months. Okay, hope it is clear.
Yes, sir.
Let's continue further. Yeah, so about the simple pendulum, we'll be learning about few concepts, like about its oscillation and time period, like what exactly these things are. So simple pendulum, it should be clear that it's simply a weight called a bob like this. There's a metallic bob here. You can see this metal ball called as bob, and it is suspended from the fixed point. Like it is hanging with the help of a thread at a fixed point. And it basically can swing forth and backward. It can swing backward and forward freely. As you can see here in the animation, how it is moving forward and backward freely. Then talking about some important things like oscillation of the pendulum. Oscillation of the pendulum. See, in this animation, you find that this pendulum is moving from its mean position and it is going to the maximum point and stops there. See, at this point, the pendulum stops over here, right? And it goes back. And at this point also, like this is the maximum point where the pendulum reaches and it stops and goes back. Getting Abhiraj, Ayush, Ibrahim and Salman, getting it?
Yes.
Hmm?
Yes, sir.
So these points where the pendulum moves to and stops, we call these different points or positions as extreme position. This is extreme position, and that one also here is extreme position. Okay. And the central position here, this one is, we call this as mean position. Like if this pendulum were to ever stop, so it will rest in the mean position. It will come to stop in the mean position, right? So talking about oscillation of pendulum. So oscillation of the pendulum is defined as the movement done by the bob of the pendulum in going from one extreme position to another extreme position. What it is? Oscillation is that when the bob moves from its center, like mean position, to its extreme end, okay, na, then it is said to have completed one oscillation. Look at the animation once again. To one oscillation of the pendulum, one oscillation of the pendulum is defined as when it moves from its starting point, goes to one extreme position to the another extreme position, and comes back to the starting point. Comes back to the starting point. So look at the arrows which I'm going to point here. That is very important. I will be calling these different positions as mean position A, extreme position B, and extreme position C. All right now? Okay. Suppose right now this pendulum is at rest. It is not moving anywhere. So it is at A now. Okay. Then from A, it moves to position B. Getting it, everyone? It from A, it moves to
Yes.
B. and B is the extreme position. A was the mean position. And from B, it now moves to another extreme position, and that extreme position here is C. That is extreme position C. And after moving to extreme position C, it comes back to the original position. It comes back to its mean position, that is A. So focus on the arrow over here. So from A, it went to B. From B, it went to C. And from C, it came back to A. Or I can simply say that it went from mean position A to extreme position B, then went to another extreme position C, and came back to its starting point or to the mean position. So this is called as oscillation of the pendulum. It is called as one oscillation of the pendulum. Tell me if this thing is getting cleared or not.
Yes,
Sir, I
sir.
have a question.
Yeah, tell me.
Sir, don't we have to say that it goes to the mean position to extreme position B, then goes to the mean position, and then goes to the extreme position?
That will basically overcomplicate it. Okay, no, that will be kind of unnecessary to mention. You can, but that does not like it will be basically lengthening your answer and does not make much sense because basically by definition oscillation
Oh,
is obviously it will be crossing through the mean position but it be going to another extreme position C. Getting it now?
okay.
So we'll be defining in the following manner that oscillation of the pendulum is defined as the movement of the pendulum sorry of the pendulum from its starting point and bracket that is mean position sorry from its starting point that is mean position through one extreme position extreme position to the sorry to the opposite extreme position and then back to its where back to where starting position in bracket that is mean position. So that is defined as one oscillation of the pendulum. That is defined as the oscillation of the pendulum. Sorry. Is that clear to everyone?
Yes, sir.
Yes, sir.
Okay. Next topic here is the time period. So time period is nothing but simply the time taken to complete one oscillation. Simply, how much time this pendulum has taken to do one oscillation is called as its time period. I hope this thing is also clear. Okay.
Yes, sir.
Okay. Next, we will do some questions on this. Okay. See, there's some noise coming from someone's side. Please sit in a quiet place. Give me just 1 minute. I need to take an empty slide. Before we move ahead, we need to understand some formulas also here. Okay, make sure that you guys memorize the formulas here because in the exam question related to the calculation of oscillation and time period, okay, na calculation of time period and frequency, sorry, not frequency, the oscillation may be asked in the exam about the frequency also, obviously. Okay, so formulas are as follows. First of all, we will find out the formula for frequency. The next will be learning about the time period. Okay. Talking about the frequency here. Okay. So frequency here will basically refer to the
Sir, what's
number
the
of
frequency?
see, frequency here in terms of the simple pendulum will mean the number of oscillations done by the pendulum here. Like how much of oscillation is being done by the pendulum will be termed as its frequency. Getting it? The amount of oscillation that will be done by pendulum, okay, that will be measured by its frequency. It refers to how many complete oscillations it is doing, like in 1 second. Okay, na? It is doing in just one minute. Let me just clarify this thing a bit more. Okay. So talking about the frequency. So frequency will basically refer to how many complete oscillation is done by this pendulum in 1 second. About oscillation, you have learned that when it moves from the starting point to the extreme points, okay, and comes back to the starting point, then it is said to have done one oscillation. No? When it will be going from the mean position A to extreme position B, goes from extreme position B to C and comes back to A. Then you will say that it has completed one oscillation. Getting it? Now let's say that you have set the timer in your watch and you have set the timer of just, let's say, 1 second only, right? So how much of oscillation it will do in 1 second will be called as its frequency. It may do 1, 2, 3, it depends. Getting it, everyone, or not?
So it's the
Sir,
more far away the extreme positions are from the mean position, the more does it become slower or faster?
Repeat again.
So like I have a doubt. If you make the extreme positions more far away from the mean position, does it become slower, faster, or equal speed?
No, it will become faster actually. Okay, no? It will become faster because then you will see that, like, if you were to move it further, no? So thereby it will be having more potential energy. Getting it now? So more potential energy means that it will lead to more kinetic energy. Getting it, Ibrahim?
Yeah, but then
So
won't the
thereby,
kinetic energy be lost out by resistance? So won't
obviously,
it
due
be
to
equal?
yeah, it will be lost due
Like
to air resistance.
there
Okay.
will be more air resistance because if it is more farther away from the mean position, means it will have more air resistance. Means there's going to be more air on the way if it's going.
Yeah,
So
but
won't
such
it be
things.
the same as if
See,
it is at another point?
basically, like what will happen if the the distance between the mean and the extreme position were to increased for this pendulum now, that we will see that if you move it further, like you move it over here, let's call this point D. So there it will be having more potential energy. It will be having more potential energy. And when it will be released from this point, it will have more kinetic energy. All the potential energy will convert into kinetic energy. So its speed is going to be increased. More kinetic energy means that the it will be having more speed. Getting it or not? And the
Yes.
factors like air resistance, it will although influence it, because of which gradually its speed will slow down. Okay.
Ah, I understand what you mean to say. You mean to say that it
Hmm.
doesn't slow it down. It
Hmm.
doesn't completely slow it down. It just like makes it stop at some point. It doesn't
Obviously,
slow
after
the like.
some point, it is going to come back to the rest now. Like say you have taken this pendulum over here in this one. Okay. So it's not like it will indefinitely keep on moving, right, Ayush, Abhiraj? Getting it? Like it's not like for indefinite amount of time it will keep on moving. Gradually after some time it will come back to rest now. Like if you were to move it further from the starting point, so it will keep on moving for longer period of time. The speed will be more. But if you were to just move it slightly, move it to this point only, so it won't be moving far. But if you were to move it this much, then it will be moving further and will be moving with more speed. But eventually it will come back to rest. Yeah.
The answer it will stop or not.
Repeat again.
The answer it will stop or not.
It will stop. After some time it will stop. Okay, let me quickly complete this. So I was talking about the frequency. Okay, so frequency, it refers to how many oscillations are done by the pendulum in 1 second. In 1 second. Okay. Further, it is measured. It is measured in hertz. Hertz here is the unit. Okay, now it is the unit. In short, it is written as capital H and a small z. Okay. So 1 hertz is basically 1 hertz is basically 1 oscillation per second. 1 oscillation.
So is there a bigger unit for it? Or
Yeah.
is this the only unit?
No, there are bigger units of frequency also. Okay, no, like hertz is not the only unit of frequency. Getting it? We have terahertz, you have gigahertz, megahertz, some other units are also there. Okay. Yeah, getting back to this once again. So I was saying that 1 hertz is basically equal to basically 1 oscillation per second. So to calculate frequency, we have a formula also.
Time is equal to speed.
Yeah.
So the formula is time is equal to speed, right?
That's a different thing. It is out of context. Look here. In order to calculate the frequency, what we basically do, as the definition of frequency is total oscillation done in 1 second. So frequency equals to total oscillation upon
Divided by the amount, divided by 1. Okay.
not necessarily 1, basically total time. So that is the formula to calculate the
If
frequency.
you do it for 10 seconds, you have to divide it by 10.
Yeah, like that. So
Right?
suppose we have
Like
a
that.
question here, like that only. We have a question that a simple pendulum does 25 oscillations in sorry, in 5 seconds. Find the frequency.
5
so moments ago you
hertz.
have learned, you're saying 5 hertz. Good. So frequency equals to total oscillation upon total time, right? So in
Sir,
the question,
this formula, it mimics the formula that we learned in maths. It mimics the formula. It's almost the same thing.
okay. Good. So here the total oscillation is given to us 25 oscillation, and time here is total time is 5 seconds. So 25 that is 5, and the unit is going to be hertz. In short, written as capital H and a small z. Ayush and Salman, pay attention here. Ibrahim, getting it, and Abhiraj.
Sir, I'm just writing the formula. I will forward as to that.
Okay, no worries. So that is how you calculate the frequency of the simple pendulum. If there's anyone who is finding it a bit difficult to understand, let me know.
So can you repeat again?
Sure. The concept of oscillation is clear or not? Abhiraj?
No, sir. Can you repeat it again?
Okay, sure. See, about the oscillation, what we have learned that like this pendulum here is doing a particular kind of movement. It is moving in a particular manner, like moving forward and backward, right? So basically, when it moves from its starting point and goes to the extreme position B, then goes to the opposite extreme position C, and comes back to from where it has started moving. So then it is said to have completed one oscillation. Like here, this pendulum is continuously moving, okay, now, but try to understand it in the following manner. Try to visualize it. That it has started its movement from mean position A, then went to another extreme position B. From here, it goes to this point, extreme position C, and now comes back to mean position from where it originally started moving. So when it does this kind of movement, to it is said as oscillation. We call this as oscillation. Getting it or not?
Yes, sir, I get
Yes,
get
sir.
Okay.
it.
Then next I told you that it must have taken some time to complete one oscillation. It obviously would have taken some time, 1 second, 1 millisecond, or whatever time. So that is called as time period of the pendulum. The time taken to complete one oscillation is called the time period. Next, we were learning about the frequency. So frequency is nothing but how much of oscillation is done by the pendulum in a span of 1 second, in under 1 second. That is called as frequency. Okay, you have to regularly revise all of this, memorize the definition, then it is going to be clear. Okay, and obviously when you will do some questions, it will be 100% clear then. Next, we learned about the time period also. So time period, the formula of time period is just the opposite.
So, sir,
Yep.
I want to tell one thing, sir.
Tell me.
So that means that this what is it called? That this pendulum has done 5 oscillations in 1 second, right?
Exactly. Exactly. It has
Okay.
moved, it has done 5 oscillations in a span of 1 second. Okay, like this animation here, it is moving very slow, but it must have been a pendulum that is moving very fast. Okay. Then the formula to calculate time period is just the opposite of frequency. See, it will be total time taken upon total oscillation. As the definition here is also saying the same thing, that the time taken to complete the oscillation. Okay, no? Particularly, it's the time taken to complete one oscillation here. Okay. So hope that thing is clear. If it is, we'll be doing few more questions now. Next question is that
Sir,
a pendulum here.
can you just show me the
Sir, can you
formula for time?
give us like one by one, like order? Can you give us like in an order?
Okay, or what you guys can do now, you can put your answers in the chat box. In that manner, now everyone will get to participate. I have
Sir,
drawn
can you
the
just show me the
documents. Yeah, look here, that's the
can you
formula.
just show me the yes, one
Everyone,
news?
everyone write down the formula. We'll be needing this. Please write down the formula first.
Sir,
Here, this
The
also
2 minute
write it fast. Oh, take your time. Write down the formula only as of now.
yes, sir.
I'll be asking formula from each and every one of you in the next class. And I will also be asking the definition of oscillation, time period, and frequency. Am I clear?
Yes, sir.
Hmm.
Yes, sir.
By the way, by the end of the class, I'll be sending the screenshots so you can memorize the definitions.
Mm,
Ayush, you accidentally have uploaded mathematics assignment. There were two such assignments that were of mathematics. Yeah.
Yes, sir. What I'm not getting.
I was saying that there were two such assignments. You were supposed to upload your science assignment, but mistakenly you have uploaded your mathematics assignment.
Yes, sir. I know that.
Yeah.
Because I was having some error in my computer, so
Okay.
that's why all whatever like I'm sending it will send
Mhm.
across.
Okay, okay. No worries. So pendulum takes, let's say, 24 seconds to complete 96 oscillations. Find its time period. Using the formula, everyone have to find it. Total time here is 24 seconds and the total oscillation here is 96. Everyone will drop their answer in the chat box only. Don't answer here. Also, one more thing, the unit of time period is basically second. Okay, now the unit, I'm writing it over here. It's basically
Sir,
second.
what
Okay.
is a pendulum?
Repeat again.
What is a pendulum?
What is a pendulum?
Yes, sir.
Like all this time we'll be learning about the pendulum only. Pendulum is basically a weight
Oh, this
that is
okay.
tied to a thread. Like you can have a metallic ball, it is tied to a piece of thread with
Oh,
a rigid
yes.
support and it basically moves forward and backward. Okay, no worries. No worries.
Sir, how
Uh,
much lines we should write?
how much? Repeat again.
How much lines we should write?
No, no, you have to basically divide the given values and get the answer. There has to be just one word answer for it. Ayush, that is not
Yes, sir.
correct. That
A
is not correct.
pendulum takes
See, it's 24 second, guys. It's 24 second. And it's 96 oscillation. You know the formula, right, Ibrahim?
Yes, sir. One
Yes,
minute
sir.
and
So it's 4 hertz.
You were not supposed to answer here, no, Ibrahim. You were supposed to
Oh,
answer
sorry,
in the
sir. I
chat
thought you were
box.
asking me for the answer.
No, I was asking for the formula,
Sir,
by
I'm
the
not
way.
able to not
Not
able
getting it.
to
Huh?
I'm not
sir,
able to
time period by
open the
total
chat
time
box.
divided.
Oh, okay. I will be resolving that issue. Yeah, Ayush. Total time upon total
4 years.
Total
oscillation. Okay, I will be giving one more question, by the way. No worries. So total time given in the question is how much, Abhiraj?
Sorry, sir.
4
No
yards.
issues. 24 hertz. Sorry,
Yes,
24
sir. 4
seconds.
hertz. Sir, 4 hertz.
Hold on. 24 second. And here the total oscillation is 96. Getting it? Okay. By the way, just hold on. You're saying how much for? No, that is not correct actually. Hold on. No. So
Yeah.
24 seconds now. 24 upon 96, that will be 1 upon
Isn't
4.
4 hertz the correct answer?
No. 4 hertz is not the correct answer. Actually, Ayush, the answer that you gave, and that is actually correct. Okay, that is correct actually. Because 1 upon 4, you can convert this into decimal, and that's going to be how much? 1 upon 4 will
1 by
be, you borrow a decimal, you take a decimal here, you'll be writing 0. 4 twos are 8. Then 4 fives are 20. So that's
so
0.25 or not?
0.25. Yes, sir.
0.25 second. Okay, no? Hmm. So that is the right answer. Getting it, everyone now?
yes, sir.
0.25 second. Ibrahim, is it clear? Yes, Salman, your answer
What?
is Salman, your answer is not correct, by the way. It's going to be 0.25 second. Why does 0.25
Sir,
second?
but how
Yeah, because see, the total time given to us is 24 second and total oscillation is 96. 24 upon 96, that will be 1 upon 4, no?
Sir,
so
we will
what
divide
about
right.
in the hertz?
Yes?
Sir, we will divide right.
Yeah, we'll be dividing it obviously.
By which number,
Sir,
sir?
the hurt.
See, basically, 24 multiplied by 4 is how much? That is 96 now. So 24 will be cancelling 96 by 4 times. Getting it or not? So it's 1 upon 4.
Yes.
And 1
Or
upon
sir,
4,
we
yeah.
sir, just we
Mhm.
can simplify divide by 24 and 96.
Yeah, we can do that as well. We can divide both of them, but
Yes, no, sir.
yeah, you can divide them by
Sir,
their HCF also. Yeah, Ibrahim, you were saying something.
sir, like I don't understand how we get 0.25. Isn't it supposed to be 4?
No, no, no. See, the numbers were 24 upon 96. Okay, 24 upon 96. Hold on, there seems to be some issue. See, it's 24 upon 96. Now you have to divide them. So, like you can use the usual method like 96. Then you will write 24 over here. Then you can write the decimal like this. Getting it now? Then you can write 96. 2s are 192. Getting it? 10 minus 2, that's 8. 13 minus 9, that is 4. Then you will take 96 times 5 right now. By the way, you will drop a 0 before. 96 5s are 480. So you're getting the answer in this manner. Also, you're getting 0.25. Okay. Or basically 24 upon 96, you will simplify it now. You guys know how to simplify, right? You take the HCF and then divide both the numbers by the HCF. So it will be 1 upon 4. See, let me clarify it further. 24 divided by 24, 96 divided by 24. So that gives you 1 upon 4 now. And 1 upon 4, we'll be dividing it in the following manner. Since 1 is not divisible by 4, so we will put a decimal here and then write the 0. Okay. Now 4 2s are 8. 10 minus 8, that is 2. Since you have put a decimal point here, okay, now, so you can bring 1 0 here. So hence 4 5s are 20. And hence the remainder is nothing. So the answer is 0.25. Got it, everyone? Got it, Ibrahim?
Yes,
Oh,
sir.
now I understand.
Okay.
Because, sir, I thought I had to like directly just divide 24 and 96.
No, not like that. Like it will be 1 upon 4, then you will further simplify it. Okay.
Okay.
So hope you guys have understood how to use the formula. Okay.
Yes, sir.
Hmm.
Sir, I cannot understand about the multiplication. Suppose, sir,
Multiplication part. Yeah, tell me.
means sir, you divided, but how you find the number 4?
Oh, how I got the number 4 here directly. Okay.
Yes.
See, that's all about like practice. See, like the number where 496 here. Okay. And it's 24 upon 96 basically. So 24 twos are 48. Okay. 24 threes, that is 72. And 24 fours are 96. So 24 will cancel 96 by 4 times now, because in the table of 24 you get 96 by 4 times now.
Yes, sir.
Okay. So like that you will get it. Next topic we'll be learning about the speed now.
Sir, I have a
Okay.
question. Sir, I have a question.
Tell me.
Sir, we got 1 by 4. We got
Yeah.
1 by 4,
Yes.
right?
Yeah.
Okay.
We got 1 by 4. Getting it. So here you are dividing 1 by 4, not 4 by 1. Like 1 here is the dividend and 4 here is the divisor. What is 4 here? It's the divisor. The number in the denominator is the divisor. You know that, right? The number in the numerator, that is going to be called
Yes.
as dividend. Okay. Yeah. So you all must have seen that in the vehicles now. They are devices like this kind of devices are installed, right? So one is a speedometer, another is a odometer. Speedometer here, like you can see, right? So it is basically like it basically tells you the current speed at which the vehicle is moving, and it is generally displayed in the unit kilometer per hour. Okay, na? So it's a device which is used in vehicles such as in cars, such as in motorbikes and trucks, which measures the speed in kilometer per hour. It basically tells you about the current speed at which the vehicle is moving. Right, everyone, getting it? Then you will see this small device over here also, right now. So that will basically display the distance that has been traveled by the vehicle so far, and that is called as odometer, and generally it displays the distance in kilometer, right now.
Uh,
Sir,
So
sir,
when
sir,
you
I
will
have a doubt.
purchase,
sir,
yeah, yeah, tell
Sir,
me.
can Ibrahim say first? I'll say then
Yeah,
after
okay, okay,
you.
okay, Abhiraj, continue.
sir, I was once reading a book, and I've heard that some people they scam other people because usually
Hmm.
people don't buy second-hand cars which have
Yeah.
gone through a lot of kilometers. So the odometer helps in showing that the car has been used a lot. And then they say that they just spin one of the front wheels which is connected to the odometer so that
Hmm.
it can go back to like a very less number. I've heard it like they do it like that
Yeah, like
sometimes.
odometer, it can. Hmm. So odometer frauds happen, and it can lead to the buyers to purchase the vehicles that are in worse conditions than they appear to be. Getting it? Getting it, guys?
Yes,
So yeah,
sir,
it
but
can
like I
happen.
have a question, like is it actually connected to the car's wheel?
It is actually connected to the.
Like I want
Please.
connected to the car's wheel,
Sir,
one of the front wheels.
Like yeah, it is like they. I'm not sure about the mechanism here, but about the fraud here, it happens. About the fraud, I can say that it happens most of the times that the buyers will be fooled. They will think that like it will appear to like it will show that the vehicle has not ran that much, but like it can be altered. Okay, na? So the odometer frauds happens. Abhiraj, you also had some
Because
questions.
I
Tell
read it
me.
from a
Yeah.
storybook. That's why.
Oh, okay. Yeah, Abhiraj, you were saying something.
sir, I have a doubt. Sir, suppose you're driving a car in 120 and more capacity, more people in the car will reduce the speed, right?
Yeah, obviously. If there are more people in a vehicle, it can significantly lead to reduction of the speed.
Okay, sir.
Got it now? That is the thing.
Yes.
Okay, so there could be a notable decrease. Yeah. Further talking about the speed,
It
like
will
what
reduce the
exactly is.
torque because it needs more. The wheels need more torque. So that's why you need to change to the second gear so that it can like sustain. It can have enough more potential energy to like drive that much weight.
Hmm. Basically, the thing is that no, like there will be more load on the engine, more fuel will be consumed. Okay, more power needs to be generated in order to move a vehicle which is more heavy. Second thing is that the load on the tires also increases. Okay, now if the load on the tire is going to increase, so thereby the friction between the tire and the ground will also increase. Getting it what I'm trying to say? Suppose there are two vehicles. One is a very light vehicle, another is a very heavy vehicle. Okay, so the wheels of the vehicle, okay, of that vehicle which is not very heavy, it will have less friction because there is not much weight upon it. But the wheel of that vehicle which is heavier, so there'll be more friction between the wheel and the ground because there is more weight above it. So
But
weight of the body also determines the friction. Yeah, Biraj.
sir, some vehicles are 4x4 and they are heavy, but they're stronger than the small cars.
Yeah, it has got to do with the construction, their construction also. Okay, now there are so many factors
Yeah,
to be
four by
taken into
four is
consideration.
4x4 is more useful, and it also counts
Mm,
about the engine design. Like if the engine design
mm,
is V8, it'll be stronger, and if the
mm.
engine design is V8 but it's smaller, it's gonna be weaker. And if the engine
Ex-
design is big but it's only V2, it's gonna be still very slow. And there's no such thing as a V2 till now.
mhm. Right. So we have different models of the engine that also determines the different factors like the speed, the torque generated of the vehicle. So that is there. Okay, na? Here about the speed, we have to learn that what exactly do we mean by this speed. Okay. So speed basically tells you about the rate at which a body is moving. The rate at which a body is moving is called as its speed. Like how can you say that a body is moving faster or it is moving slower? One thing is that you can observe it. Okay, now you can say that okay, this body appears to be moving faster, this appears to be moving slower. But if you have to be very specific, like how fast it is moving, how slow this body is moving, then you need to calculate its speed. Then what you need to calculate the speed. So speed is defined as the rate at which a body is moving. Okay, a body is moving, and it is calculated by dividing the total distance traveled by the total time taken. So it is found out by dividing total distance traveled by the time taken. Further, this speed can be measured into different units. You can measure it in meter per second, kilometer per hour, miles per hour, etc. But the SI unit to measure the speed is meter per second. That is meter per second. In short, we write it as m/s, that is meter per second. Other units are as follows. So you have got kilometer per hour.
Sir, I have a doubt.
Yeah, tell me.
Since suppose a small car is small, but
Abhiraj, your voice is stucking.
maybe some internet issues is happening. Sir,
Turn your camera off and then ask. Turn your camera off and then ask the question. Uh, yeah, continue.
sir, a small car has suppose it's a Lexus car. Sir, it's stronger than the 4x4.
Okay.
Whose car is stronger than 4x4?
See, I really can't understand what you're saying.
Sir, I want to hear the question, sir. Sir, I want to hear the question.
Yeah, but like his voice is not coming clearly. Abhiraj, please repeat the question.
Sir, 4x4 cars is better than a sports car.
Oh, you're saying 4x4 cars are better or sport cars? Sport cars.
Yes,
I want to say sports car.
Sir, he's saying, he's saying, does the 4x4 cars have more potential than the sports cars?
Oh, okay. See. Both of them have some pros and cons. Okay, now when we talk about the 4x4 car, like so they have superior off-road capacity. Okay, now like they have good grip and control on the uneven surfaces also, whether it be on mud, snow, or any other challenging surfaces. Getting it? But they have some disadvantages, like they have lower fuel efficiency. Their price could be more. Getting it? Now? That is the thing. And when we talk about the sports car, so sports car are designed for speed. Okay, now they are designed for speed, for acceleration, right now, and like they are very responsive. Like it will be enjoyable experience to drive them on the twisty roads. Getting it now? So sports car, they are designed for speed, for acceleration, and for sharp handling on the twisted roads. Getting
Sir,
it?
sir, I understand what
But you cannot draw the
he's
drive
trying
them
to
on the.
say if the
Yeah.
engines are strong.
Oh, if you were to compare the engine
Sir,
of the
I
4x4
think he's
car
trying to
or
say
the sports car.
he's telling which one has more power. So the sports
Okay.
car will have more power or the 4x4? The 4x4 has torque, but if you were able to make their torque similar, the sports car would have more speed and torque. This sports car would have more speed, right?
See,
Because like a commercial car, its engine cannot be very powerful. But
mhm,
as a sports car, for example a Pagani, it
mhm.
would need a very large engine. Like for example an F1 car. So he's trying to say, would it have more power capabilities than the 4x4?
Okay, okay. See, generally what we see that, like a 4x4 car basically focuses on high torque engines, since it has to be driven over the off-road also. You need to ensure that it has off-road capability, like it can
So yeah,
drive on yeah,
like suspension.
yeah, like suspension. It should have good suspension. It should have good amount of power in it. While when we talk about the sports car, so it emphasizes upon having having higher acceleration, having rapid acceleration. Getting it now?
So
Less
Also,
like in
torque.
yeah.
So you're
engine.
having less weight and less torque. Less
Hmm.
weight, less torque, and
Yeah.
stronger engine, but
Yeah.
still lightweight.
There's one more thing. Okay, na. So in the 4x4 engine, although the torque is going to be higher, but the RPM should be low, so that it will be durable and it will be able to handle it in the challenging areas, in the mud or in the sandy or in the rocky areas. Getting it now?
So it shouldn't be very like strong engine. If it's a very strong engine,
Hmm.
they'd have to somehow reduce the torque so much, and it would be very hard
Yeah,
to do
several
that.
things have to be taken into consideration. Okay, na? Several things have to be taken into
Like
consideration.
they would need like 2 or 3 worm gears.
Hmm. That is the thing. Okay, so we'll be stopping the discussion here. All right, we'll be discussing about the speed and we'll be doing some questions in the next class. Okay, na? We have learned that the speed is simply